Hi folks, welcome back to the fourth video in 7.2 Law of Cosines. So we're going to continue on our practicing. We've got two last examples to practice decision making, and we're going to start here with number 5. So by now this should be a pretty intuitive first step is draw a diagram and label your diagram. And so we've got 29.7, we've got 41.5, and 27.2. All right, so let's see what we can do with this. Do I have enough information for law of sines? So sine of 29.7 over 27.2 equals sine of b over 41.5, which equals sine of c over little c. So I've got one full pair, almost a full pair, definitely not a full pair. So I could use law of sines here for this, okay? So if we use law of sines, let's see what we get. Let's start off here and find our b. So, find angle B. All right, so I'm going to start by taking this pair, these two pairs, and I'm going to cross multiply. 27.2 sine B equals 41.5 sine 29.7. I'm going to divide. And I'm going to turn that into a decimal. All right. So I am going to be super careful about what cases I have though, because look at what I have. I have a side, and an angle. All right, so that means that when I'm looking at this step, I have to consider two different cases to find my angle B. All right, so let's set the stage for that. We're going to do case number 1, which is what we just plug into the calculator and see what it gives you. So if sine B equals 0.7559, here's what your calculator will tell you is angle B. It will tell you that angle B is 49.104 degrees, okay? Now, once we have angle B, we're going to go ahead and find the other angle. So we're going to find angle C, and I'm going to do that just by doing 180 minus the first angle minus the second angle. See what I get. And I'm going to get angle C to be about 101.196 degrees. Okay? And our last step then will be to find little c. So I'm going to write out step 3, find little c, and I'm going to do that by using law of sines. Okay. Now, just because we've done this quite a few times at this point, I'm going to cross multiply and divide in the same step. So I'll have 272 sine 101.196, but then I'm dividing by the thing I multiplied c by. And when I put this into the calculator, let's see what we get. And we get a c of 53.854. And do we have units for this? We do. It's meters. So that is our third side, okay? All right. Now, because this was a pain in the SSA case, we have to go ahead and try case number 2. So we know we have at least one triangle. Our question now is, do we have a second triangle? So let's do case number 2. So let's say that angle B is actually 180 minus 49.104. All right. That would make angle B equal to 130.896 degrees. Okay, so that is our other possibility. So let's see if we can find an angle C. If we can find an angle C, that means there's a second triangle. Okay, so we're going to do 180 minus 29.7 minus 130.896. And we'll get angle C equals super small, but there is enough for a second possibility. All right, so we've got a small angle C, but that's because angle B took up a lot of the degrees. Now we're going to find the little c that goes with this triangle. Okay, so I'm going to set this up the same way. 29.7 over 27.2. And except this time I'm going to assign of 19.404 over little c. Okay? Now just like the last time, I'm going to skip the step where I cross multiply, but I'm going to say if I had cross multiplied, I would get this. And then I would divide by the thing I multiplied c by. Okay? And when I type that into the calculator, I get I get a C value of 18.239 meters. Okay? So again, this is the one case we really have to be careful of, which is the pain in the SSA case, because there might be two triangles, and it's up to you to make sure that you check for both. Okay? All right, let's take a look at this last example here. Let's get our triangle going. A and B and C. Okay. So let's set up our triangle and see. Now, already I can tell that the first two are not full pairs, and this third one is not a full pair either. So what does that mean? That means that we need to use law of cosines, okay? And in this case, we're going to use law of cosines to find side A because we have angle A, all right? So A squared equals B squared plus C squared minus 2 times A times B cosine of 41.4. Okay, so 2.78 squared plus 3.92 squared. So again, I like to kind of lump those two together, less writing, less typing into my calculator. Minus 2 times 2.78 times 3.92 times cosine 41.4, and that gives me minus 16.349. So I did all of this together, and that gives me A squared. And so A is going to be the square root of that difference, 23.0948 minus 16.348. And that will give me an A value of 2.597 yards. Okay? Now again, when we use law of cosines, we really just want to use it that one time and then see if we can find everything else through law of sines, all right? And so that's what we're going to do here. We found our A using law of cosines, and now we're going to find our B, angle B, all right? So I've got sine of 41.1 over my newfound A equals sine of B over 2.78. So I'm going to do that same thing where I cross multiply and divide in the same step. So cross multiply, divide, and find that decimal. .7079, okay? And that gives me an angle B of about 45.065 degrees, okay? Now that's really nice because the last thing I'm looking for is angle C, so I can take what I know about angle A and angle B, add them together, and then subtract from 180 to find angle C, okay? So let's do that over here, right? We've got angle C equals 180 minus the angle we were given minus the angle that we found. And so that will give us angle C as 93.535 degrees. Okay, let me zoom back out so we can see the whole question 6. All right, but we found our A using law of cosines. Then we used law of sines to find angle B. Then we used our knowledge of degrees inside of a triangle to find angle C. All right, and so now we have solved our triangle. All right, so we're going to stop it here for this part of the video. Come on back where we're going to take a look at those really neat area formulas where you can find area without knowing any angles in the triangle or even just knowing one angle in the triangle. Okay, see you there.